Very good morning, everyone. We are going to start a new chapter, Current Electricity. This is chapter 8 for class 10. And the first thing that we are going to know is electric charge. So, what is electric charge? Electric charge is an additional property of a particle, of particles, due to which the particles experience a force of attraction, and this force of attraction is greater than the gravitational force of attraction that caused by the mass, caused because of their masses. So if A and B are the two charged bodies, then this A and body attract one another, and here the attraction, the force of attraction is greater, as because those two bodies are charged bodies, so there is an additional attraction. So this force of attraction is greater than the gravitational force of attraction, that is numerically equal to the gravitational force is numerically equal to g mass of A into mass of B divided by d square. So now whatever the force of attraction in between those two bodies, those two charged bodies, is greater as compared to this force, this gravitational force. Okay, now for the charged particles there is a one more additional property, that is, if the two charges are kept near to one another, then there may be one more thing possible, that is the repulsion in between those two charged particles. So here electric charge also causes a force of repulsion in between two charged particle A and C. Here in the place of B we have taken C. So this C and whatever the observation that we got here, it lead us to a conclusion that there are two types of charged particle, two kinds of nature of charge. Here the A, body A is identical to that body A. Okay, but here we have taken body B, which is attracted toward the body A, and here the body C, which is just opposite to the body B. Okay, and that's why it is repelled by the body A. Correct? So we have two types of charges, two kinds of charges, two nature of charges. So one that body B has, and just the opposite kind of charge that the body C has. So one of the charge is called positive charge, another is called negative charge. So there are two kinds of charge, two nature of charge, positive and negative charge. We know about electron. So electrons, all the electrons are the negatively charged particle, whereas the protons are the positively charged particle. Okay, so these are the two kinds of charges. Now see the property of charges. Like charges, two like charges repel each other. That means if we have electron, then it repelled by any other electron or any other negatively charged body. That means two negative charged body or negative charged particle repel one another. So in the same way, if we have two bodies, okay, two positively charged bodies, like one particle is proton and other is also proton, so the proton is repelled by other proton or any other positively charged body, like so. If two like charges are there, there is a repulsion. Two unlike charges attract each other. This is the other property. So example is given here. One electron can attract the other proton. Okay, one electron can attract by a proton or any other positively charged body. That means if we have a positively charged body, then this positively charged body will attract an electron or any other negative charged body. So attraction in between two like charges. Now see the movement of charge. Movement of charge, when the charge will start its motion. So it is quite simple. If we have a charged body, positively charged body here, then this positively charged body try to attract this negatively charged electron toward this, and in this way this electron will start to move. Okay, suppose for the support, if we give here, if we place here one more negatively charged body, then this negatively charged body will push the electron, whereas this positively charged body will pull the electron. So there is a movement of electron, movement of charged particle, that is the movement of electron in between those two charged bodies. Okay, this arrow shows the movement, and here there are 2 points B and A, and we will say that the electron is moving from point B to the point A. So this is because of the force of attraction and repulsion. Here this body causes force of repulsion, whereas this body causes force of attraction. Overall there is a movement of charge in between those two bodies, those two charge body, this one and this one. Correct? So here the movement of charge, that means when the charge comes in motion, we will say that there is a current, there is a flow of charge. So let's see. First we will know about the unit that is used to measure the charge. So the charge is denoted by the capital Q or small q, and the unit is Coulomb. It is named by a scientist whose name is Coulomb. So it is the SI unit of electric charge is Coulomb, and it is denoted with the letter capital letter C. And as we know that the smallest charge particle is electron, so that's why we are considering what is the magnitude, what is the amount of charge in an electron. So it will be given as minus 1.6 into 10 to the power minus 19 Coulomb. Okay, the unit is Coulomb. So this is called the electronic charge. Okay, and it is represented with a small e, and whenever it is given that E, that means E equal to minus 1.6 into 10 to the power minus 19 Coulomb. So the same charge, as the electron has this charge with a negative sign, the same magnitude of charge, but the positive charge of a proton it is A. Okay, so charge on a proton is plus 1.6 into 10 to the power minus 19 Coulomb, whereas in an electron it is minus the same. Okay, so now the question arises, suppose we have a number of electrons or protons, then it is multiplied with the electronic charge and it will give the total amount of charge. Okay, so suppose we have number of electron into electronic charge, it will give an amount of charge that is termed as Q or plus minus Q. So if we want to get the number of electron or proton, then it will be, see, this is the formula, n equal to Q by E. Okay, we are just doing the simple mathematics here. So one of the numerical is solved here. Number of electron in 1 Coulomb of charge. So we have Q, that is the total amount of charge, it is given as 1 Coulomb. Okay, and number, to find out the number, we have the formula n equal to Q by E, and this U, that all you know, it is 1.6 into 10 to the power minus 19 Coulomb. If you solve this, we will get the number 6.25 into 10 to the power 18. So this is the total number of electrons present in 1 Coulomb of charge. Suppose we have a charged body and the charge in the body is 1 Coulomb given it is, and it is given as minus 1 Coulomb, then the total number of electrons present in the body will be that much. This is the total number of electrons present in that body which has the charge minus 1 Coulomb, correct? So this is the task given, calculate the number of electrons present in a body of charge 0.5 Coulomb and 2 Coulomb. You can calculate this one. Now see the flow of charge. As in the previous picture, it is clear that here it is clear that if two bodies are placed here or simply one body is placed here, so it will causes the movement of this electron, that is called movement of charge. Okay, so the flow of charge that we are going to know, the flow of charge or the flow of charged particle, electron or proton we can say, but basically the proton are fixed, so that's why we are saying that electrons. Okay, so first we will know about conductor, because in order to get electron, we have to consider the material, the body which has electrons as its constituent particles. So here the electrical conductor means all the metals are electrical conductor, as you all know, and in a electrical conductor body it has a large number of free electrons. Okay, large number of free electrons, and those electrons moving randomly in the body of the conductor. See, this is the body of the conductor, and here you can see the electrons are given, and the arrows shows that the random motion of the electrons. See, it is not definite, that means the movement of the electrons, the motion of the electrons are not definite, they are randomly moving around the body of the conductor. But suppose we apply a negative charge body, that means we apply an electrical push by giving a negatively charged body here by contact on this end, on this right end, and this positively charged body here on this left end. So if those two are connected, then what happened, these electrons are attracted by this positively charged side, and these electrons also pushed or repelled by this negatively charged end. So what happened, the electrons will now start a motion in a definite direction in the body of the conductor. Then we will say what, the electrons, the charge is start to moving, there is a flow of charge in terms of electrons. Okay, but remember that there is no it is not possible that all the electrons as a bulk moving toward this. So it is the electrons only drifting toward this. That means here the protons are also present. So this term I will clear you later, but here just assume that the electrons are moving toward this, and this will causes the flow of charge. So this term is clear, the flow of charge is clear. Now see the next point, electric current. So as we are studying about flow of charge, so how the electric current is related? Current means the flow. Okay, so here the current of charge, that means the electric current. The current of charge, or in other word we can say, in other word we can say the current of charge as flow of charge. So here this is what we call electric current. The flow of charge is called electric current. So let's see the flow of charge through a cross section given here A of a conductor. So this is the cross section A. You can see, you can easily understand. So this one is the conductor, and this one is a single conductor. Here not any join, but here A is marked only to show this one is a cross section, and the electrons are passing this cross section, pass to this cross section, and then after we are considering. So now the total amount of charge Q, it is given. If Q is the amount of charge passed through the cross section, it is small a. Okay, so this one is the cross section. So total amount of charge passed through the cross section in a given time t. Then we will say what is the rate of flow of charge. That means the flow of charge in unit time. So it will be the total amount of charge Q divided by the time t. So I, that is the electric current, is equal to Q by T, and it is defined as the rate of flow of charge, or we can say that it is the flow of charge in unit time. So this is what we call the electric current. Okay, but this one also can be written here. You can see Q can be written as any, as the number of electron into the electronic charge. Here E means electronic charge and divided by time. So Q can be written as any. So this is also the formula. So in this way we will define the electric current as the rate of flow of charge or the flow of charge in unit time, like that. And now come to that point, what will be the unit of electric current? That you all know, in SI the unit of electric current is ampere. It is named by a scientist. And one more thing, if we want to define 1 ampere, then we will say that 1 ampere is the current passed through a conductor in 1 second. This is not the current, it is the charge. Okay na, 1 ampere is the charge that passed through a conductor in 1 second. Correct? Now see this one. So there we will know about the flow of current, the direction of flow of current. So in this picture you can easily, this I refers to the electric current, because the electric current is denoted with the letter capital I, or small I we can use. So here this I refers to the direction of current. So here you can see the electrons are flowing toward this, and the current is opposite to their direction, the flow of electron, opposite to the flow of electrons. So this is what we have. See this line, the direction of flow of current is opposite to that of electron. That is, the direction of flow of current is always from positive end to negative end of the conductor. Correct? Now we are going to know about the electrical energy. So here the electrical energy of positive or negative charge. Here this positive charge has an electrical energy, that's why it is pulling the electron. Correct? So this causes a movement of electron, so that means it has potential, it has some potential energy. So the electrical energy of positive or negative charge end, negative or positive charged end of the conductor causes the motion of the charged particle inside the conductor. And if this causes the motion, so that means there is a displacement, and with a force of attraction. See this one is the also given that there is a displacement, the charges are in motion, so there is a displacement, and with a force of attraction, that means there is a force. So if there is a displacement and force, what we will say, there is a work. So an amount of work is done on the charged particle, okay, on the particles by the charged end, this one and this one. So these two charged end done some work on this charged particle. So if work is done on the charged particle, then what we can say, we will say that these particles will gain some energy because work is done on the particle. Correct? So let's see. Now we are going to know about the electric potential. See, we have a charge Q in the space. Correct? So this is considered, this one is a charge Q that is considered in the space, and now these are the point A, B, and this is the infinity, point infinity. Let's see. An amount of work is done, as in the previous point, as I said, that an amount of work is always done on a charged particle, okay, on a charged particle by any other charged body. So like here, q is the charged body, so an amount of work is done on q. So this one is a q, another charged particle, so this is taken as a test charge. This q is a test charge. So an amount of work done on this q by the charged q, by this body. Okay, so work is done on this q by this charge body. So we will say what, this body q, this charge, test charge, will gain some energy, as because work is done on this body, correct. On this test charge some work is done, so we will say that the test charge gain some potential energy because work is done on the body. Okay, so here the electrical potential energy that gained by the test charge is exactly equal to the work done on the test charge. Whatever the work done on the test charge is equal to the electrical potential energy gained by this test charge. Okay, so consider 3 points. We have the 3 points, okay, and in those 3 points what the energy that the test charge will gain. So let's see, at the point infinity, so this is the point infinity, and there is no force of attraction here at the infinity, so we will say that there is no any work done. That means there is no any energy for this charge q. So test charge q at the infinity, it has zero energy. So energy is zero at the point infinity. At the infinite point, for the charge, for the test charge q, the energy is zero, correct. Now see that second point we are considering at the point B. So here at the point B, so we will say that some work is to be done on this test charge to carry the test charge up to the point B. Okay, so work done on the point Q to displace from, suppose we are considering the charge is initially, the test charge is initially at the infinite point. So from infinite to B it is displaced, and due to this displacement is with the force of attraction or repulsion by this charge. So we will say that force of attraction actually. So we will say that the work is done on this test charge q, then see the work done can be written as wb, and this amount of work done is gained as the energy by the body, by the test charge q. So this is the energy of the test charge q at the point b, and it is equal to wb. That means the work done on the test charge q by the body, by the charge q, to carry up to the point, to bring up to the point b, correct. So when it is brought from infinity to b, there is some displacement and there is some force, so there is some work done on this body, and this work done is stored as a electrical potential energy for this test in this charge. Okay, so we will say that the energy of charge at q is equal to wb, that is the work done, correct. Now this is same as at the point a. You can read the third line. The energy at the point a can be written as wa, which is equal to the total work done for displacing the charge, test charge, from infinity to a, correct. Now electrical potential that we are again, so here we have considered about the energy only. Okay, the energy of the test charge at different point, and here we are going to know the electric potential. So let's see, we have this one is the energy at the point a for the test charge, and this one is for the test charge b, and here it is 0. Now the electrical potential energy gained by the test charge q at the point, at any point a or b, is equal to the amount of work done as it is given here. Okay, so this work done is by the test charge, by the charge q, charge body q. That means whatever the work is done, it is by the work charge q, and bringing this test charge to that particular point from infinity. Okay, suppose the test charge q is taken as 1 coulomb. Suppose this test charge q is taken as 1 coulomb, then we will say that this is the electric potential, and this electric potential of a charge q at a different point, like here the point A, here the point B. At the point A, this q has some energy. At the point B, this q has some energy. As you can see in this figure, at the point A, this q has the energy Wa. At the point B, this q has the energy Wb. Different energy at different point. Okay, at the point infinity, this q has a energy 0. So this energy at any point is exactly equal to the work done to carry this charge up to that point. Okay, and this work done is by the charge, this charge. So we will say that this charge, because of this charge, the work is done. So for this q charge, the electric potential at different point A or B or C anywhere is equal to the electric potential at the point, at any point, is equal to the electric point of the charge q at any point is equal to the amount of work done in bringing a unit positive charge, that is plus 1 coulomb charge. Test charge is taken as plus 1 coulomb from infinity to that point, and this is what we call the electric potential. You can clear the concept here. See, I am saying that here at the point B, this test charge q has some energy which is different from the energy at the point A. So that means because of this charge here, this q has some energy and which is different from the energy here. So we will say that there is a difference in energy. Okay, so at different point, this charge q acquire some different amount of energy. So we will say that this q possesses a different potential here at the point A, and here at the point B, and here at the point C, or anywhere like that. Correct. So at any point, the potential of this q charge is equal to, is given as the amount of work done in bringing 1 coulomb of charge from infinity to that point. So this is what we call the potential. So now what is the formula for potential? So as electric potential is given as work done per unit charge for 1 coulomb of charge, so it is the work done per unit charge, so W by Q. So at the point A, the potential is VA, can be written as, see, potential is denoted with the letter capital V. So VA, that means potential at a point A is equal to work done, it is WA. Okay, WA, that is work done to carry the test charge at a point A, so it is W by Q, and here at the point B it is WB by Q. Okay, or in general we can write W equal to V equal to W by Q, work done by charge, or the work done is equal to V into Q, that is potential into charge. Correct. So what will be the unit of electric charge? So by the formula you can easily detect, that is work by charge. So for work it is, the unit is joule, and for charge it is coulomb. So work by charge, that means joule per coulomb, and this joule per coulomb is named as volt. Volt is a SI unit, is the SI unit of electric potential. And now if we want to define a volt, then the electric potential at a point is said 1 volt when 1 joule of work is done in bringing 1 coulomb of charge from infinity to that point. Okay, so we are saying that if here at the point A the potential is 1 volt, so that means this test charge Q is plus 1 coulomb, and to carry the test charge plus 1 coulomb from infinity to that point A, 1 joule of work is done. Then we will say that at the point A the voltage is, the potential is 1 volt. Correct. So this is, the potential is clear. So here we clear about the potential, electric potential. So now to see what is potential difference. Now the same figure that we have. Okay, so we are saying that work done in bringing the charge, the test charge, from A to B. So now it is considered from A to B only. It is considered to brought from A to B. So now the work done can be written here WBA, that is work done to carry the charge from B to A. Correct. Now as we know, the energy at the point A is WA, and the energy at the point B is WB. Okay, so here at the point WB the energy is WB, at the point B the energy is WB. Now if work is done, so there is some gain in energy, and this work done to carry the charge from B to A is equal to WBA as it is given. So this and work done is now it is stored as a potential energy here at this point. So we'll say that now there is a gain in energy when the work is done on the test charge in bringing from B to A. So there is some work done, and this work done is stored as a potential energy, and already at the point B it has the energy WB. So this WB is added to this WBA. So whatever the energy here, this energy is added with the work done to carry from. So at the point A we will say that at the point A the energy at the point A is equal to whatever the energy at the point WB at the point B is added with the work done from B to A, correct? So we will say that this difference in work done, so this is WA, okay na, WA minus WB, remember that this is WA minus WB equal to WBA, okay, that is work done difference in energy at the point A and B. So at the point A the energy is subtracted, and see it is a minus WB, that is energy at the point B is equal to the work done to carry the charge from B to A. Now what is the potential difference? This point is clear. So here we are going to know about the potential difference at the point in between B. So simply we have the potential at the point A is VA, and at the point B it is VB. So the potential difference V is the difference in potential. We know that this VA WA by Q, this can be taken small q, or we can take here capital Q because test charge can be taken Q. So WA by Q is the potential at the point A, and WB by Q is the potential at the point B. So it is WA minus WB divided by Q, and this WA minus WB is the amount of work done in bringing the charge from B to A, correct? So we will say that WBA divided by Q. So this is the potential difference, or we can directly say that the potential difference is equal to V, and it is equal to work done divided by the charge. So it is the work done to carry the charge from one point to another point, okay, and this work done divided by that charge gives the potential difference in between those 2 points, okay. So as this charge Q is carried or brought from B to A, so we will say that in between B A the potential difference is whatever the work done divided by that charge, correct? Now we have the definition of potential difference. The potential difference in between 2 points is equal to the work done in bringing a unit positive charge, because this charge can be taken as a unit positive charge because whenever it is divided. So here as it is divided, so we will write here at the denominator 1 coulomb, correct? So it is in bringing, it is the work done in bringing a unit positive charge from one point to another point. Suppose one point is B, another point is A. So in bringing A to B, whatever the work done, this is termed as the potential difference, correct? So potential difference is a scalar quantity, and the unit is again volt, because it is potential. Difference means potential, okay? So it is, the unit is volt. So thank you class.